Hello, Algebra System. Mr. Lawrence here, and today we're going to learn to graph quadratics, which means graphing parabolas. A parabola is the shape of a quadratic equation. Just like a linear equation shows up in a line, a quadratic equation will show up as some type of view. Okay? Now, we're going to use the quadratic formula that we've learned. We're actually going to use parts of it to do some very special things. I do want to point out to you that when you graph your parabola, it will not be like two lines. It won't be a V like the absolute value. It will be a U, and it will have a vertex. It will always have a vertex, which will be the highest or the lowest point. So let's remember the quadratic formula. X equals negative of b plus or minus the square root b squared minus 4ac all over 2a. Now, remember we learned that this is called the discriminant. And we're going to use this when we go to graph our parabolas. It's going to tell us how many solutions are. Now, be warned, if we get no solution, it doesn't mean we're not going to graph. It just means that our parabola won't cross the x-axis. Remember, I've mentioned in the past two videos that the solutions are the roots of the quadratic. They're the place where the parabola crosses the x-axis, okay? What we're going to do then is we're going to find our vertex, and we're going to use this part of the formula to help us find the x-coordinate of our vertex. Once we know that, it'll be really easy to graph. So let's see how this works. Okay, first of all, I am going to use the discriminant, b squared minus 4ac, to find out how many solutions there are. So first of all, I need to say that I need a, b, c, easy as 1, 1, negative 12. All right, I'm going to plug those into the discriminant. So I'm going to get b squared minus 4ac. And when I do that, simplify using the order of operations, I'm going to get 1 plus 48. A negative times a negative is a positive, which equals 49. Since this is greater than 0, there's going to be two solutions. So I'm going to proceed with the quadratic formula and figure out what the two solutions are. Now, if there had been no solution, I wouldn't waste my time going to the quadratic formula. I would just go to the vertex, which you don't know how to do yet, but that's okay. I'm going to show you. So now I plug in the quadratic formula, and I'm going to work really smart. I'm going to go x equals negative b plus or minus 49. I'm not going to waste my time writing 1 squared minus 4 times 1 times negative 12. I already did that. I know it simplifies to 49. I'm just going to put 49 in there. Okay, over 2a. So x equals negative b plus or minus square root of the discriminant over 2a. And I'm going to simplify this as best I can. So I'm going to get x equals negative 1 plus or minus square root of 49 is 7 because it's a perfect square. This is a rational number, right? Square root of 49 is rational. It ends up being a decimal that ends. 7 is a decimal that ends. And that's going to be all over 2. So I have two answers here. I have x equals negative 1 plus 7 over 2. Or x equals negative 1 minus 7 over 2. And when I simplify those, I'm going to get x equals 3. Negative 1 plus 7 is 6. Divide by 2 is 3. Or x equals negative 4. Now remember, I said these were the places where the graphs cross the x-axis. So my points are 0, 3, and negative 4, 0. Those are said to be the roots of the quadratic. I'm going to plot those 2 points. 1, 2, 3, 0. And then I'm going to clone that point so he looks good. And he goes to negative 4, 0. 1, 2, 3, 4. All right, now I need the x-coordinate of the vertex. And that's going to happen on a line of symmetry. So let me see if I can find the x-coordinate. I'm going to use only the negative b over 2a part of it. And I know b is 1. How do I know that? Remember I did a, b, c. Easy as 1, 1, negative 12. Well, I'm not going to use the negative 12. I'm just going to use the a and the b. So I'm going to get negative 1 over 2 times 1, which is negative 1/2. So my line of symmetry is going to be the equation x equals negative 1/2. Now remember, we talked about vertical lines, right? And what their equations are, they're always x equals some number. So what's going to happen is, I'm going to make him a little thinner, is that along this broken line, which is not really a part of my graph, the parabola is going to be symmetric. Each point on the right-hand side will be equidistant to a point on the left-hand side from this line of symmetry. It'll be symmetric about it, okay? So let me find the rest of my vertex. I've got the x-coordinate of my vertex. So if you think about it this way, maybe an input-output table, I'm going to say x, and x is negative 1/2. I'm going to plug y into the original equation. Right here, I don't know what the heck that is. All right, so see this right here? I'm going to plug negative 1/2 in right there. All right, so I've got y equals x squared. Was it minus x or plus x? I think it was plus x minus 12. So plus x minus 12. Wherever I see an x, I'm going to substitute in a negative 1/2. And when I do that, I'm going to get y equals 1/4 minus 1/2 minus 12. Now, make this easy. If I add $0.50 minus 1/4, I'd have 1/4 left, right? This is going to simplify to negative 1/4. This answer here, I'm going to highlight it. This one here is twice as big as this number here, ignoring the negative. So when I combine them, I get half left because it's a subtraction problem. All right, if you don't understand, I'll try to explain that a little bit more, trying to build that number sense. Minus 12, so then y is going to equal negative 12 and 1/4. All right, so I know my vertex. The vertex is going to occur at this point. It's going to be negative 1/2, negative 12 and 1/4. All right, so I'm going to go up to my graph and I'm going to plot my vertex. And it'll take a little bit of guesstimation. I don't want to count by a different number like 2's or something. I'm just going to kind of guesstimate. I'm going to erase this stuff out of my way. Hopefully you already have it down. And I'm going to need to put a vertex somewhere. So on that. So I need to go to negative 1/2. This would be negative 10. 11, 12 and 1/4 would be right there. And it's hard to tell where that is, so I'm going to label it so that the reader knows what point that is. Now, you're going to have to forgive me. I can do this much better on the smartboard than I can in the class with the airliner. But my parabola doesn't look very good, does it? Is going to be a perfect U shape. I know, you'll have to forgive me. It's not a perfect U shape. I still haven't mastered that skill. I can make the other half identical to this half, though, which I guess is a good thing. And it's going to look like that. What you're going for, and it'll be easier with pencil, is you're going for that classic U shape, something like that. Okay? It will not be straight. It will not go vertical. Okay? It really shouldn't look this bad, and I feel so ashamed and embarrassed. I wonder if I can kind of manipulate this one. Hold on one second. Now, it won't let me manipulate it. It's only allowing me to make it proportionally bigger. I want to change its size, but it won't make it skinnier. Anyway, so let's try one more. Okay, first thing I'm going to do, identify A, B, C. So A, B, C. Easy as 1, 0, negative 6. Then I'm going to go to my discriminant. B squared minus 4AC. I'm going to plug in the values. B squared minus 4AC. and I'm going to get 0 plus 24, which of course is 24. I'm going to have two solutions. They're not going to be rational solutions. They're going to be decimals that never end, never repeat, just like pi. They won't be pi, but they'll be like that. So I'm going to go to the quadratic formula, and I'm going to get x equals negative of b plus or minus the square root of the discriminant. Again, I'm not going to rewrite all of this. I already know it equals 24. Okay, all over 2a. And so I'm going to simplify, and I'm going to have x going to equal plus or minus square root of 24, which is an irrational number, over 2. Because there is no square root of 24. There is no number times itself that equals 24. This is an irrational number. Just like pi, it goes on forever without repeating. Now, I'd like to get some decimal approximations of that, so hold on a second. Okay, I've got my calculator up, so I'm going to do the square root of 24, and I'm going to divide it by 2. Got to be careful with that, close that parenthesis right there, because if I don't, I'll be doing the square root of 12, okay? Got to be careful with that. So it looks like it's going to be about 2 and 45 hundredths. Pretty close to 2.5, but just shy. So let's see, where is that? So the positive one is going to be x. Oops, I'm not in right mid. Write for me, please. It won't change. Something's wrong. I don't know what's going on. Let's see. Okay, so. Wow, it's acting funny. All right, well, I guess I can make this work. We're going to get x. No, we're not. Hold on a second. Okay, not sure what happened, but what did I get? I don't remember. It was 2 and 45 hundredths. So I'm going to go ahead and round it because trying to graph the other one is like really tough. So, okay, I'm going to get 1, 2 and a half. Going to be right about there, so it's just going to be a smidgen short of that. And since it's an unusual number, I'm going to put its label on the graph. Okay, and that's a rounded answer. And then in this case, it's not normally this way, but in this case, the other one would be x equals the negative 2.45. Okay, because the b was 0. So I'm going to go 1, 2. Okay, now. My axis of symmetry can be found by doing x equals negative of b over 2a, which negative of b is 0 over 2 times 1, and 0 divided by 2 is 0. Hopefully you've mastered that by now. If not, this is not your opportunity. So my axis of symmetry is the y-axis. I normally would make it smaller, but in this case I'm going to keep it nice and big so that it shows up. There we go. Okay, now I'm going to find the vertex. I know the x-coordinate of the vertex is 0, so all I do is I plug 0 in for x into the original equation. So my original equation was y equals x squared minus 6. So the y-coordinate of the vertex is going to equal negative 6. Some of you are probably thinking, geez, it's always going to be a negative. No, not always. 2, 3, 4, 5, 6. There's my vertex. I will try to draw my parabola as best I can. Oh, that's looking lovely. There we go. That's a little bit better. Now it looks like it might go vertical. It really doesn't. Okay, it never goes vertical. And again, I apologize for the kind of sloppiness. It's just so difficult to do with the airliner. Okay, so it's going to look something like that, and then I'll do them in class for you, and they'll look much better. And something like that. Remember, it never goes vertical, and you are striving to draw a nice, pretty U, just like that. Okay, so let's do one more, and then we'll call it quits. All right, we have a more complicated one here. Let's find A, B, C. Easy as 9, negative 24, 16. All right, now I go to my discriminant. B squared minus 4AC. So I do negative 24 squared minus 4 times 9 times 16. Okay, and, okay. So I want to say 576 for 24 squared, but I don't remember exactly, so pardon me. Yeah, it sure is, 576. So we're at 576 minus, and 9 times 16, if I triple 16, I get 48, right? And if I triple that, I'm going to get 144. If I double that, I'm going to get 288. And if I double that, I'm going to get 576. So this discriminant is going to equal 0. There's only going to be one solution. So what's going to happen in this case is my vertex is also going to be my root. They're going to be the same point. The vertex is going to be sitting on the x-axis. So I'm going to go to the quadratic formula. X equals the negative of b plus or minus the square root of the discriminant all over 2a. All right, and so what I'm going to get, this plus or minus won't matter. I'm going to get one solution. It's going to be 24 over 18. If I divide by 6, I get 4/3, which equals 1 1/3. That's the x-coordinate. I don't need to go finding the y-coordinate because remember, I know there's one solution. I know my vertex is sitting on the x-axis. If you didn't know that, you could plug 1 1/3. Don't use 1.3. You have to use 1.3 repeating. In fact, maybe I'll do that just to demonstrate it. Into the calculator for the original equation, and then you will you'll get 0 out. So let me go ahead and do that just in case you're not following me, because normally we would plug it in. So the original equation is 9 times, and then I need 1.3, or I could use 4/3. 4 divided by 3 like that. Okay, that's going to be squared. Order of operations, it'll square the 1/3, 1 1/3 first, and then multiply by 9. I need minus 24 times 4/3 and plus 16. Okay, look at that, I get 0, just like I thought. I knew that because my discriminant was 0, that the only solution I get would have a y-coordinate of 0. It's going to sit on the x-axis. So let me put it on the x-axis. 1 1/3 is right there. Now, I need some points. I can't draw my parabola yet. So I'm going to make an input-output table. And I'm going to be very, very smart here. I like to put 0 in for x whenever I can. So I'm going to plug 0 in for x. And when I do that, I'm going to get 16. And I think on this one, I am going to go ahead and count by 2's on the y-axis. Okay? I'm going to count by 2's on the y-axis, still counting by 1's on the x-axis. So when I put 0 in, I get 16 out, right? I'll get y equals 9 times 0 squared. Well, that's just 0. That's gone. Minus 24 times 0. Well, that's 0 plus 16. So 0 plus 0 plus 16 is 16. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, so right there. Now, remember I mentioned that thing about symmetry? This is really cool. This makes graphing parabolas very simple. How far apart? Oh, I should have put that axis of symmetry in. Let me put that axis of symmetry in this problem. It's 1 1/3, I think, right? Okay, now watch this. I love to work smart and not hard. Hard work is good. Smart work is way better. Okay, it looks like it's about at 1 and 1/3. It's pretty close. How far apart, how far is this line, oops, from the axis of symmetry? Well, I think it's 1 and 1/3 away, isn't it? Sure, 1 and 1/3. The next x value I'm going to put in is going to be 1 and 1/3 on the other side. If this point is at 1 and 1/3, what's 1 and 1/3 plus 1 and 1/3? Well, I think it's going to be 2 and 2/3, right? 1 plus 1 is 2. 1/3 and 1/3 is 2/3. So I'm going to plug 2 and 2/3 in. And I'm not going to do any work because I know the y value. Because of symmetry, it's going to have to be 16 also. So this is 1 and 1/3. This is 2 and 2/3 will be right about there. And my parabola is going to be symmetrical in that way. And I'm going to go ahead and try and draw it. Move this out of my way. And I'll draw it in blue as best I can. And so, again, I apologize. I can do it so much better at the chalkboard. That's like the one thing that is worse with these smart boards. There isn't much that's worse. That's it. Drawing parabolas. All right. So, here we go. All right. So, there it is. There's my parabola. All right, that's it. We're going to get some practice with this over the next couple of days. And I will talk to you later. Mr. Lawrence signing out. Have a good night, everybody.